Good afternoon, students. In previous class, we have seen what about the derivation for de Broglie's wave equation as well as MVR is equal to NH by 2 by the two derivations we have seen. Next, I have started with spectrum classification. Okay, how many types of spectra we have? Two types of spectra. Those are emission spectrum. So 1 minute now. Emission spectrum, absorption spectrum. Okay, first we will see emission spectrum. One small clarification now, 1 minute. Spectrum is of two types. Continuous, discontinuous. If any mistake is there, just correct that one. In yesterday's means in previous class, if I told any, here I wrote emission, here absorption, like that if I wrote by mistakenly, you can correct. Otherwise, this is correct one. Okay. Spectrum is of two types, continuous, discontinuous. Under discontinuous, again two types of spectra we have. Sorry for this one. Under discontinuous, emission and absorption. Again under emission, two types are there. Line spectrum, which is atomic spectrum, and another one is band spectrum, which is molecular spectrum. This is the classification of correct spectrum. Okay, now we will see. First thing is continuous and discontinuous. Difference we will come to know. Okay, when sunlight is passed through prism, you will get 7 colors on the screen. Okay, my question is, between one color and another color, any gap is present? No gap. Is it correct? Yellow, that red color, which gamma? Violet, indigo, blue, green, yellow, orange, red. There is no gap between one color and another color. That is continuous spectrum, which is formed by sunlight. Correct? That is example for continuous spectrum. Artificially, if you take any element or molecule or any absorption or anything, whatever it is, in our lab, if you create, not with sunlight, if any other spectrum, if you are able to get, okay, that is discontinuous spectrum. Under the discontinuous spectrum, again two types are there, emission spectrum and absorption spectrum. Emission spectrum, line spectrum and band spectrum. Absorption spectrum, only one type is there. Okay, now clearly we will see this continuous spectrum, no need for us. This is simple thing only. We know rainbow, formation of rainbow, all these things. These are coming under continuous spectrum only. Now coming to discontinuous, we have two types now, emission and absorption. First we will see emission spectrum. Okay, ma'am? Emission spectrum, already you know the process of formation of the spectrum also we have seen in hydrogen spectrum. Okay, let us consider any one atom. Suppose this container contains H atoms. This filament contains tungsten atoms. Correct? Whatever the element might be, it is heated at high temperature. if it is heated at high temperature, we will get light out. When that light is passed through prism, we will get spectrum. Like this we will get. This is spectrum of tungsten, this is spectrum of hydrogen atom. Like that, depending on the element, that spectrum is different. These are all examples for emission spectrum. Why this is called emission spectrum? Okay, what is happening inside? See, let us consider H atom. H atom contains nucleus, one electron in ground state. Okay, when this H atom is heated, see, this is heated. When this is heated, it is absorbing the energy. Electron is absorbing the energy, and that electron is going into high energy state. In that high energy state, it will not be stable. Then that electron will come to ground energy state by the emission of energy. This is emission. Emission means releasing. This energy which is emitted, this is emission. The energy which is emitted when it is passed through a prism, we will get spectrum. That's why this is called emission spectrum. Okay, if you take atoms, we will get lines. Suppose this is appeared as this tungsten like this. This is one line, this is one line. Okay, now instead of atoms, if you take molecules, we have molecules. Molecules means group of atoms. No? At a time, 3 or 4 electrons will be excited to higher energy. Again, they will come to ground energy, release more amount of energy. Correct? And that energy is passed through prism. Same like this we will get, but the thickness of these lines will be little bit high, because this is formed by atom, no? One atom only. This is molecule, group of atoms. Group of atoms means the resultant will be group of lines. Group of lines is appeared as one band. Little bit thick. When compared to the line, this is little bit thick. This is one band, and this is called band spectrum. This is line spectrum, and this is band spectrum. Both are coming under emission spectrum. This is formed by molecule, no? This is formed by atom. That's why line spectrum is also called atomic spectrum. Band spectrum is also called molecular spectrum. This is about emission spectrum. Completed. Now we have absorption spectrum. Before going to that one, observe the board clearly, all of you. Spectrum is of two types, continuous and discontinuous. Under discontinuous spectrum, further two types are there, emission and absorption. Under emission again, two types are there, line spectrum and band spectrum. Okay, this line spectrum is formed by atoms and band spectrum is obtained by molecules. Both are same only, which are formed by emission of energy only, but the thing is, in line spectrum it is appeared as one line, band spectrum the group of lines appeared as band. Okay, that is the thing. This is complete information about emission spectrum, and this is bright line on dark background. What is that? Bright line on dark background. Like this is one color and this is one color. Colored lines, background black. Colored lines, background black. This is about emission spectrum. One more time. Bright line on dark background. Dark means black. Bright means colors. In yesterday's class, I have sent some videos now. In that videos, difference between emission spectrum and absorption spectrum you have seen. Okay, how emission spectrum is there, background is black, on that different lines of colors with gaps present. Okay, that is about emission. Coming to bands, bright bands on dark background, same thing. Background is black, on that colors will be appeared as color lines. Colored lines on black background. This is about emission spectrum. Now I will go through absorption spectrum. Okay. Okay, coming to this absorption spectrum, now let us consider same hydrogen atom. Electron is present here. It is getting heated. Means some amount of energy is given from outside. The energy which is given from outside is not enough to transform this electron to energy state. This energy which is given by us is less amount of energy. The energy which is given by us is less amount of energy. That energy is not sufficient to make this electron going from ground energy state to high energy state. Then that electron will not move from lower energy state to high energy state. It will be present in that lower energy state only. Okay, but what is going to happen? By the absorption of this energy, little bit this electron is getting vibrated. Little bit. That electron is getting vibrated like shock, like this. It is getting vibrated and absorbed by electron. It is not releasing any, it is not emitting any radiation. Please observe carefully. It is not emitting any radiation. Simply that is absorbed by electron. That's why this is called absorption spectrum. Then how the spectrum will be formed? See carefully. This is total light. This is total light. This total light, when it is fallen on electron, particular part is absorbed, remaining is coming out now. Particular part is absorbed and remaining is coming out. Remaining colors, when they are passed through prism, correctly the line which is absorbed by electron, remaining colors they will come out. And when it is passed through prism, we will get spectrum as lines. Lines. But how the lines will be observed? Okay, it is observed as schema. This is the screen. Background is colored. Here, background is colored. Background is colored, but like this one line is formed. This is dark line, black line, and one more line is formed like this. Previous one here we have observed like this one. Now completely reverse. This is absorption spectrum, this is emission spectrum. Okay, one example I will tell, you will understand clearly. Okay, I am standing like this, little bit front. I am standing like this now. Light is falling on me. Okay, back side of me, if you observe, it will be shadow. Imagine this total wall as screen. Okay, screen, I am standing like this, light is falling on me. Imagine that light is absorbed by me. I am observing the light. Okay, back side, black color shadow is formed. Correct? Like a line it is. Black colored line. Correct? Now, if you see the back screen, screen is filled with light on it. Screen is filled with light. My body, instead of my body, we have shadow. Like that, one more person is standing there. Back side of him also shadow. One more person is standing there. Shadow. Between shadow and shadow, we have light. Between shadow and shadow, we have light on the screen. I am talking about on the screen. On the screen, one shadow is here, another shadow is here, another shadow is here. Between the shadows, see, shadow means dark, black color. This is another shadow, black color. Between that, light is there, na? That is bright color. Okay. Now, this is emission. This is absorption. In emission, we have bright lines, dark background. This is bright background, dark lines. Why? Here electron is not going to exit state. It is absorbing the light. The light which is falling on that electron, it is absorbed. Remaining light will be falling here. Okay, correctly where that electron is there, at that electron shadow is appeared. Remaining light fully colored. Like that, different electrons are present. In presence of that electrons, gaps are present. Okay, after completion of this, one more time I will send that image. In that image, it will be clear with two diagrams. Okay, this is clear. I hope you are clear about emission spectrum and absorption spectrum. By this, spectrum is completed. Okay, observe the board, all of you. Please remember, in absorption spectrum, dark lines, bright background. In emission spectrum, bright lines, dark background. One more time I will send the image in our group. By that you will be more clear. Okay, this is about spectrum. I hope you are clear. Just observe the board. After that I will start with one more topic in this atomic structure. Okay, correctly where that electron is present, that electron is absorbing the energy. So that energy which is absorbed by the electron, it is created as one dark line on the screen. Remaining light, it is bright color on the screen. So where are the electrons which are absorbing the radiation? Instead of them, we are getting black colored lines. Black colored lines on dark background. That is in absorption spectrum. Okay, ma? Next. Next thing is wave nature of light. Not wave nature, nature of light. That one I will start. Before that, one more time, just I am recalling today what did I explain. Spectrum, I started with spectrum. Spectrum is of two types. Those are continuous and discontinuous. Continuous already we know, Wedge formation on screen by the passage of sunlight through prism. Okay, coming to discontinuous spectrum. Discontinuous spectrum is of two types. Those are emission spectrum and absorption spectrum. Under emission spectrum again two types are there, line spectrum and band spectrum. Coming to absorption spectrum, this is the thing. That is the difference between emission spectrum and absorption spectrum. Okay, ma? I hope you are clear about this spectrum. I think next we are going to start with the nature of light. Okay, let's see the side heading. Nature of light. So why we have to study nature of light? Okay, by studying the nature of light, easily we can correlate dual nature of electron, because light is also contained by dual nature, particle nature as well as wave nature. Okay, now in olden days, ancient history time, name of the scientist Newton, he tried to explain the nature of light. He tried to explain the nature of light, and he proposed one theory called Newton's corpuscular theory. In the olden days, Newton tried to explain the nature of light, and he proposed one theory called Newton's corpuscular theory. Okay, according to this theory, Newton considered light will travel from source to object in the form of particles which are called corpuscles. Newton's corpuscular theory considered light will travel from source to object in the form of particles only. Those particles are given by the name corpuscles. Okay, so this scientist, Newton, tried to explain the nature of light by considering that light as a particle only. He did not consider wave. Like Bohr, Rutherford, Joseph Thomson, they did not consider electron as wave, correct? They considered electron as only particle. Like that, Newton considered light as particle only. When he considered light as particle, he explained the particle nature, but he could not explain wave nature of light, which were some properties of light were not explained. Those are diffraction, interference. These are the properties of light. Which were not explained by Newton's corpuscular theory, because these are the properties which can be explained by considering wave nature of light. Without considering wave nature of light, we cannot explain the diffraction and interference of light. That's why Newton's corpuscular theory kept aside. It considered light as a particle only. But after some years, next scientist, Heiden, he proposed one theory called Heiden's wave theory. What is that now? Heiden's wave theory. According to this Huygens wave theory, light will travel from source to object in the form of waves. Light will travel from source to object in the form of waves. He considered the wave theory of light, wave nature of light. So he explained diffraction, interference, and all the wave properties. Even by some particular properties also explained. Particle nature is also. But main particle nature properties are photoelectric effect, and black body radiation. Photoelectric effect and black body radiation were not explained by Huygens wave theory because these two are particular matter, means particle nature. These two are explained by considering particle nature of the light. Diffraction, interference, these properties are explained by wave nature of light. If you consider wave nature, we are not explaining these theories. If you consider particle nature, we are not able to explain diffraction, interference. Okay, so two scientists, Newton, Huygens, separately they considered particle nature and wave nature. They did not succeed completely. That's why next, after some more years, one more scientist kept forward by name Max Planck. What is the name? Max Planck. He proposed a theory by considering both natures, wave nature as well as particle nature of light. By considering both wave nature as well as particle nature of light, and it is called dual nature of light. And it is called dual nature of light. Okay, and he explained the theory, and the theory is called Planck's quantum theory. So first theory, Newton's corpuscular theory, next Huygens wave theory. Finally, now we are studying nature of light by this theory only, that is Planck's quantum theory. Planck's quantum theory. Okay, now what is the Planck's quantum theory? How it is successfully explained dual nature of light. Dual nature means both particle nature as well as wave nature. Okay, let us see. This is the bulb which gives out light. Okay, in which this is the source. From this source, light will come out. This Max Planck explained in a way that light will come out in the form of a group of waves. In the form of group of waves. Okay, between one group of wave and another group of wave, small gap will be present. Between one group of wave and another group of waves, small gap will be present, like this. And he named this and this one and this one contain same energy, means fixed amount of energy, and he given this one as energy packet, and he given the name of this one as energy packet, which is called quantum. Quantum means fixed amount of energy. This energy packet has fixed amount of energy. This energy packet has fixed amount of energy. As the source is same, all the energy packets have same amount of energy. Okay, one more time. From the source, light will come out and it will reach the object and it will reach the object in the form of both particle as well as wave. How did he explain both particle as well as wave? See, this is like group of waves. This group of waves like a bundle which is called energy packet. First this group of waves will come out. With a small gap, next group of waves will come out. This is like one energy packet. And with a small gap, again next energy packet will be released. Each one is called one energy packet, which is called quantum. Each one is called quantum, and group is called quanta. And group is called quanta. Inside of this one, if you observe, wave nature is there, and this total bundle is treated as like one particle. This total bundle is treated like one particle. This is one particle. So it succeeded to explain the dual nature of light by considering both wave nature as well as particle nature. See, this group of waves are there now. This bunch of waves treated as one particle. Bunch of waves treated as one particle. Inside again waves are there. Means it contains both wave nature as well as particle nature. Okay, and that energy packet, each energy packet is called quantum. Each energy packet is called quantum. Are you okay, ma? This is Planck's quantum theory. Now, each quantum energy is directly proportional to frequency. If frequency increases, frequency means number of waves that can pass through the particular point in unit time. If it increases, energy of the bundle also increases. Correct? Number of waves that can pass through the particular point in 1 second, if it increases, energy of the bundle also increases. So E is directly proportional to nu. E is directly proportional to nu. This is called frequency of light. E is called energy of light. This is directly proportional. By removing directly proportional, we can keep one constant. That is E is equal to h nu. These two will be replacing directly proportional. Okay. This h is called Planck's constant. Now E is equal to energy of light. E is equal to energy of light. H is equal to Planck's constant. Nu is equal to frequency of light. Nu is equal to frequency of light. E is equal to energy of light. H is equal to Planck's constant. Nu is equal to frequency of light. This is E equal to h nu. This is one energy packet, but how many energy packets are released from that bulb? We don't know. Let it be n. So we can write E is equal to nh lambda, nh nu. What is that n? Number of energy packets released from the bulb source. Once again I will write now. Before that, observe the board, all of you. Max Planck considered light will travel from source to object in the form of both wave nature as well as particle nature. Okay, now light will come out from the source in the form of energy packets which contains fixed amount of energy called as quantum. One energy packet is called quantum, group of energy packets called as quanta. Okay, now each energy packet quantum energy is directly proportional to frequency of the light. E is directly proportional to nu. When nu increases, E also increases. Then by removing the directly proportional, we can keep one constant. E is equal to h nu, where h is equal to Planck's constant. Planck's constant values And what about E is equal to NH nu? Everything once again I will write ma. Okay, shall I rub the board? I hope you are clear. So three theories now we have studied. Those three theories are: first one Newton's corpuscular theory, second one Huygens wave theory, third one Planck's quantum theory. First one, Newton considered only particle nature of light. Second one, Huygens wave theory considered only wave theory of light. And third one, this Planck's quantum theory considered both wave nature as well as particle nature. And every property of light was successfully explained by Max Planck. Wave properties like diffraction interference, particle properties like photoelectric effect and black body radiation. Everything was successfully explained by Max Planck, and we are going to correlate same dual nature with dual nature of electron, in which electron contains both wave nature as well as particle nature. That's why we are studying this one. Okay, now I am going to rub this one, and again I am going to explain the terms. See all of you. E is equal to NH nu, where N is equal to number of quanta, H is equal to Planck's constant, which is equal to 6.625 into 10 power minus 27 Earth second, which is equal to 6.625 into 10 power minus 34 joule second. Okay, nu is equal to frequency. Frequency is not a constant. According to the given problem, we can fix that one. Okay, now since nu is equal to C by lambda, we know the formula nu is equal to C by lambda, then this formula will become E is equal to NH C by lambda. NH C by lambda, where C is equal to velocity of light. It is a constant, 3 into 10 power 8 meter per second, 3 into 10 power 10 centimeter per second. Okay, lambda is equal to wavelength of light. Lambda is equal to wavelength of light. These are the useful formula to do the problems. E is equal to, sometimes they will not mention N. At that condition, simply we will take E is equal to H nu, E is equal to HC by lambda. Please remember, these formulae are highly useful for doing the problems. E is equal to H nu, E is equal to HC by lambda. Did you remember in Bohr's atomic model, when electron jumps from higher energy orbit to lower energy orbit, E2 minus E1 is equal to H nu. That H nu is nothing but radiation. That radiation is coming out in the form of energy packets called quanta. Okay, Bohr considered that quanta, and he told E2 minus E1 is equal to H nu. This is about dual nature of light. Okay, everyone? Okay, observe the things. Values are also very important. In different units, you have to be in a position to remember the values, because in what way the problems will be asked, we can't estimate. So we have to be very careful about the units also. E is equal to H nu. H is equal to Planck's constant. H values 6.625 into 10 power minus 27 Erg second, which is also equal to 6.625 into 10 power minus 34 joule second. Nu is equal to frequency. N is equal to number of quanta. Those are not fixed values. That's why we cannot give that values now. Now next, E is equal to Hc by lambda. C is again constant. C is equal to velocity of light, which is equal to 3 into 10 power 8 meter per second, which is equal to 3 into 10 power 10, that is 3 into 10 power 10 centimeter per second. Lambda is equal to wavelength of light. Okay, that is about this nature of light. In next class, by using particle nature, how can we explain photoelectric effect and black body radiation, we'll see. By that, complete light nature will be completed. After that, how we can correlate this one with electron. Okay, already we got some information. Okay, that de Broglie's wave nature is there, na? As well as MVR is equal to NH by 2 pi. Already that information we got. Okay, that is nothing but by considering wave nature of electron. By considering wave nature, already they considered particle nature. In what way we can proceed with next explanation, we will see. I hope you are clear about today's class, everyone. Okay, no doubts at all. How this nature of light is explained by taking dual nature, in the same way we can explain the drawbacks of Niels Bohr by considering the dual nature of electron. Dual nature is nothing but both particle nature as well as wave nature. Okay, in next class we will continue about all those things. That is about today's class. Thank you all.